All right, welcome back to Coding with Culp. Today is a great day to learn how to code, and this is part 2 of my Hunt the Wumpus using Python and Pygame. So if you didn't see part 1 of the video, I'll link to it down below. And part 1 basically just explains what the game is, what it's about, and gets a basic skeleton of the game up and running so that you can walk through the maze essentially. So what I decided to do this time for part 2 was, instead of going through it line by line, coding live line by line, is I just let you download the whole program, every bit of it, and then I would go through it and explain how it worked. Maybe that would give you a good idea of how the game worked, and you would understand it enough that you could then go and make changes to it if you wanted to, or learn enough that you could go write a game similar. Now, before we do that, you've got to figure out how to get the code and the graphics. So down below in the description, I'm going to put a link to download a zip file for that'll have the code and the graphics. I don't know exactly how that link's going to be. I don't know where I'm going to store it. I don't know if I'm going to put it in Dropbox or if it's going to be a link to GitHub or something like that. But whatever it is, it's going to be a zip file. And so if you're doing this on the Raspberry Pi, I need to show you how to unzip a zip file. And there's a few different ways that you can do it. If you're doing this on Windows or on Mac, it's pretty simple. Right-click on the file after you download and extract it. Now on the Raspberry Pi, we got to install a little bit of software. We got to install zip and unzip. And it's pretty easy. I've opened up a terminal window. In fact, I'll just come over here and right here, terminal window. And you're going to type in sudo apt-get install zip, and that's going to install zip for you. Now I've already got it, so it tells me it's all automatically or already installed. Then you need to install unzip. What I'm going to do, I'm going to press the up arrow key, and all that does is it cycles through my last commands, and I'm going to do the same command, just unzip, and same thing. I've already got it installed, so it tells me that, but yours should install it. If it asks you yes or no, just say yes. Now there's a couple of different ways that we can unzip this file. Way number 1 is to use the command line interface. Let's say you download the file. It's probably going to go to your download section. So if I do ls, which stands for list, that gives me a list of all my directories. You notice that one of them is downloads. I can go cd downloads. And there we go. Now I don't have it here. Let me move it there real quick and I'll show you how to do this. All right, let me Control C. Control V. There we go. Okay. So there it is. It's in my downloads directory, wampus.zip. Now all I got to do is just do unzip wampus.zip. Also, just in case you don't know this shortcut, I just typed in WU and then press tab. And it tries to match a file in that directory that starts with WU. In this case, that was the only file that started with WU, so it completed it for me. I just press enter. And as you can see, it inflates it all. When I type in ls, there's my directory, Wampus. And I can go cd Wampus. Let's try that again. cd Wampus. And there it is, wampus.py, and then the images directory, and I'll take you through all that in just a second. Now, there's another way to do this. After you've installed zip and unzip, you can use the file manager. So I'm going to click on the file manager, and then I'm going to go to downloads. It's decided to lock up on me. Let's try this again. All right. Oh yeah, great. Great. It's decided to quit. All right, the Windows Pi does not seem to be responding. Do you want to force to exit by sending the term signal? Let's end process real quick. All right, let's try this again. All right. So I open up the file manager. All right. I'm going to go to the downloads directory. There we go. Okay. So here it is, wampus.zip. All I got to do now is just right-click on it. I right-clicked, okay, and I don't have the button held down. I'm going to go archiver, okay, or I'm sorry, extract here, and there it is, Wampus. Now, if you wanted to, you could also, if you have a coding directory, you could take this and move it to that directory. Like I've got a coding directory that I made right there. So I could come over here to downloads and I could just drag and drop it to coding and it will go there. Although I think I've already got this file there, so it's going to probably, maybe I didn't. I didn't. Anyways, I've actually got it all unzipped and it's all right here. So inside of, that's the wrong one. I guess I don't have it on here. Okay, so let me just hang on just a second here. Let me rename this Wampus. Okay, now let me unzip this one. Extract here. There it is, Wampus. Okay. So when I open it up, I have wampus.py. That's the Python file. And then I've got a directory called images, which has some images that I'm going to use, like the image of the bat and the actual Wampus. Some gold, although I'm not using the gold. Now, let's dig into the code. Okay, let's go ahead and dig into the code. All right, I'm going to start my exploration of the code at the setup area, which starts on, looks like line number 326. So these are the globals and constants area. And what I do is I set two variables called screen width and screen height, and I set them equal to 1,000. That's the pixels, the width and the height of our window in pixels. I could change this if I wanted to. I can make it 800 or 400 or 10,000, although don't make it really above 1,000. Especially if you're on the Raspberry Pi, it won't fit on your screen. Then this is where I load the images. Okay, that's where I load the images. I make a variable called bat_image. And I use a Pygame function called load, pygame.image.load, and all it takes is the file name of the image. And notice it's images/bat.png because images is the directory that it's in. It's in a subdirectory of this directory called images. And I do the same thing for player image, that's the player, the Wampus image, and arrows. Then what I'm going to do is I'm going to set some things to set the difficulty level of the game. The number of bats we want in our maze, and the number of pits. And then the number of arrows that are scattered throughout the maze. I put 0 arrows, so you're only going to have one arrow, the arrow you start with. And if you fire it and miss, well, then you're dead. Then what I do is I set up some more variables. Player POS equals 0. This is going to track what room the player is in. We're going to start them out in room 0. In reality, we're actually going to do it randomly. But for now, we're just going to set it to 0. And same thing with the Wampus position, going to set it to 0. But we're going to determine those in just a minute. We're going to set the number of arrows that they start with, the person starts with, or is on their person to 1. That's different than this one. And I know this is confusing and probably bad programming design. I probably shouldn't have done this. But the one in all capitals, okay, the one in all capitals is the number of arrows that are scattered throughout the maze that the player can find. The one in lowercase is the number of arrows that the player currently has. Then we're going to set mobile Wampus equal to false. What this means is that the Wampus is going to sit still. He's not going to move. If you set it equal to true, every time the player moves, the Wampus will have a chance to move. And you can set that here. So if you got mobile Wampus set to true and you set this to 50, that means every time the player moves, there is a 50% chance of the Wampus moving. To make the game harder, put in more bats, more pits, and make the Wampus mobile. And then set the chance that the Wampus moves. The higher the chance the Wampus moves, the harder the game becomes. All right, then I set some constants for directions. Up is going to be equal to 0, down 1, left 2, and right 3. So that I can just refer to those directions as text, up, down, left, right, rather than some numbers 0, 1, 2, or 3. You'll see what I mean. I set some color definitions for brown, black, and red. Those are the main colors I'm going to use to draw with. Brown is going to be equal to 193 red, 154 green, and 107 blue. Black is, of course, 0, 0, 0 on red, green, and blue. And then red, I set it to a medium red, but a little bit of green and blue. Then we come to the main data structure for this whole thing. That's the cave. If you do not understand this data structure, please go back and look at video number 1 where I explain dictionaries. The cave is a dictionary. Oh, you know what? Let's actually take a look at the cave and what it looks like. I'll just explain this again real quick. What did I do with the cave? It's right here. Okay. So our cave is a dodecahedron, a 20-sided shape, or excuse me, a 12-sided shape. And the vertices where the shape collides, or the vertices of the shape, represent the rooms. And then the edges of that dice, or that shape, like I said, go see video number 1. I do a much better job of explaining it. Represent the tunnels connecting those rooms. So room number 1 is connected to room number 2 on the left, room number 5 on the right, and room number 8 going down. In addition, we kind of made a convention that anytime the player is moving towards the top, we're going to call that up. So moving from 12 to 3 is up, 14 to 4 is up, 17 to 7 is up, etc. Anytime they're moving away from the center, we're going to call that down. Anytime they're moving, if you're standing in the room, like room number 19, and you're looking up towards room 11, this is left and this is right. Even on room number 20, this is left and this is right. Okay? I think I got that one right. Room number 16, when you're looking at room 15, looking towards the up, this is left and that's to the right. All right. So let's go back to here. So what this is a dictionary. This tells us the key. Room number 1 has exits, and this is up, down, left, and right. Room number 1 goes up, down, left, right. Okay. If you go up from room number 1, there is no exit. That's what that means. 0 means, hey, there's no exit in the up direction from room number 1. And we can check that out and see. Going up from room number 1, there is no exit. Going down goes to 8, and left is 2, and right is 5. So yeah, up, down, left, and right. If we went down from room number 1, we'd hit room number 8. If we went left from room number 1, we'd hit room number 2, etc. Then we have a couple lists. The bats list, the pits list, and the arrows list. All it does is contain room numbers. That's it. Where the bats are, the pits are, and the arrows are. If there's any arrows laying around to find. A little bit more initialization area. We're going to print the instructions. Oh my gosh, you got to be kidding. Print instruction. Oh wow. Looks like I screwed up. And wow, I even spelled it wrong up here. All right. If that's not fixed in your version before I zip it up and put it up for upload, you can feel free to either keep it the same or fix it. Then what we do is we say, so it prints instructions. We say input, press enter to begin. And so it's just waiting on empty input. You can press enter. We initialize Pygame. Then we set a variable called screen that we're going to draw to. And that's pygame.display.setMode. Now notice in parentheses, because it's expecting a list or a tuple, we're going to put our screen width and screen height. Then I tell it a little thing here where you want a double buffer. Basically what we're going to do is we're going to draw to a background screen. And then we're going to, after all our drawing's done, we're going to move that screen, that buffer, to the front so it all gets drawn at once. It's not too needed on this game, but on a really fast video game or something like that, you'd really want that double buffer. And then we're saying, hey, if you can get a hardware surface, in other words, if your computer has specific hardware for drawing graphics, use that. That'll speed things up a little bit. But this right here, this pygame.hw surface is completely optional, and in fact, in many cases, doesn't actually do anything. We're going to set the caption of the window. We're going to call it Hunt the Wumpus. We're going to now load our images. Ooh, did I do this twice? I did. Wow. That is, all right. I'll get rid of it up here. It doesn't really matter. Actually, you know what? I'm going to get rid of it down here since I already talked about it. Oh, we can't. Let's get rid of it up here. Let's get rid of it up here. I don't even know why it's doing there. I'll probably fix that before I upload it. Maybe, maybe not. All right. So we load our images. We're going to set up our font. We're just going to use the standard system font, 36 point. And then we call this function called reset game. Let's go look at reset game, see what it does. So let's go find reset game. There we go. All right. So what we're going to do is we set a global variable called, or we tell reset game, hey, reset game, listen, we're going to be writing to a variable called numarrows. Numarrows is actually a global variable that's set outside of reset game. So we want to declare it as global so that when we write to it and we set it equal to 1, we reset the player, basically says, hey, you got 1 arrow, that it does it properly. And we call this function called populate cave. Let's go look at populate cave. All right, populate cave, what it does is it does just what it says. It's going to populate our cave with the player. And all we do is we say, hey, the player position is random from 1 to 20. Okay, 1 to 20. And actually, you know what? I really think, 1 to 20. Random.random, 1 to 20. Then we call this function called place Wampus. So let's look at place Wampus. What it's going to do is it's going to put the Wampus in the maze. So what we do for place Wampus is we say, we've got another error, 1 to 20. Once again, you might want to fix that. I don't know if I'm going to fix it before I upload it. So anyways, finding all kinds of errors here. What we're going to do is we're going to say, hey, the Wampus position is equal to the player position. Now, we don't actually want that, do we? We don't want the Wampus and the player position to coincide at the beginning of the game because that would result in an immediate death for the player. So what we're going to do is we're going to set that. The Wampus position is equal to the player position because we know that that's not what we want. Then what we're going to do is we're going to say, hey, while the Wampus position is equal to the player position, assign a random position, a random room number, to the Wampus position. So let's say the player position is 5. So Wampus position and player position are now equal to 5. So what we're saying is while Wampus position, while 5 equals player's position, which it is true, assign another random number to Wampus position. Go up here and test it. Now if they're not equal, we know that the Wampus and the player are in a different spot, which is what we want to start. So we exit out of that while loop and go back to populate cave right where we ended off, which was right here. So now we're going to place bats in the cave. For bat in range 0 to num bats. Okay, so what we're going to do, if we have 5 bats, we're going to go 0, 1, 2, 3, and 4. And we're going to place a bat each time. I'll go over the bat placement function, but it's exactly the same really as the Wampus function. We're going to set the bat position equal to the player position. Because remember, we don't want that to happen. We actually don't want the bat and the player to be in the same spot at the beginning of the game. So because we know we don't want that to happen, we're going to say, hey, while the bat position is equal to the player position, or the bat position, I'm going to put in some, or the bat position is in bat's list. Basically, we're saying, hey, if the bat position and the player position are the same, or the position that we've generated is already in the bats list. In other words, there's already bats in that room, or the bat position is equal to the Wampus position, or the bat position is in the pits list. In other words, we don't want bats and pits in the same room. Choose a random number for the bats. Then go back up here and test it. Once again, if all of these fail, we now know it's a good number. It's not the same number as the player. It's not currently a room that's in our bats list. It's not equal to where the Wampus is. And it's not in a room with a pit. So then we just do bats list.append bat position. What that does is it adds that number onto that list of rooms that we have for bats. All right, populate cave. Now I am not going to go over the pit function because it's exactly the same as the bats function. It's just testing for pits. And I'm not going to go over the arrow function because it does exactly the same thing as the other two functions do, only with arrows. Now, I print out all this information of where the player's at, the Wampus is at, the bats and the pits and the arrows, only because of debugging information. When I was writing it, I needed to make certain that my functions were working. You may very well, once you are sure everything's working, comment this out so you don't know where everything is. But once again, for now, I'm going to keep it in there just to show you that everything's working when we run it. All right, so we did populate cave. So now let's go back to reset game. So once reset game populates the cave, sets the number of arrows down to 0, it comes all the way back down to here, and now it starts our main game loop. All right. The main game loop, all it does is it checks for events, draws the room in the background buffer. Remember that background buffer. Then it flips that background buffer to the front so we see it. And then it checks the room to see if the player is in a bad room. Either a room with the Wampus and you die, or a room with a pit and you die, or a room with a bat and then it moves you. So let's do this. Let's come up here to check Pygame events. Right here. All right. This might be the most complicated of all the functions we're going to take a look at because it's a giant if, else, if. And I'm going to be honest with you. When I'm programming, I don't usually like to do this. You know, if you've got 17 levels of ifs and else ifs, oftentimes it's easier to separate those out. But in this case, it does actually make sense to do it this way. So all check Pygame events does is it's going to check to see if keys are pressed on the keyboard. Okay, like up, down keys or escape key. So we're going to set the player position as global. We're saying, hey, listen, check Pygame events. We've got this variable called player position, and we declared it outside, okay, of your function. But we're going to want to modify it in here. So we're just letting you know it's a global variable that we're going to modify. We're going to get the next event. That's what pygame.event.poll does. It gets the next event. And then we're going to say, hey, if event.type, if it's equal to pygame.quit, the user has pressed the escape key, the user has pressed the X button, you know, the X button to exit. Go ahead and pygame.quit and exit. Or if event.type equals pygame.keydown, okay, if it equals keydown, that's all of this is going to be gone through. So here we go. It's really not that difficult. Else, if event.type equals pygame.keydown, we know we've pressed a key. And basically we're saying, hey, if that key is the escape key, quit and exit. Then we're saying if it's the left key, okay, left arrow key, we say if pygame.key.getMods and pygame.kmodshift, basically all this means is if they've pressed the left key and the shift key is down, we're going to shoot our arrow to the left, and we'll look at that in just a minute. Else, if cave.playerPosition left is greater than 0. In other words, if, remember our cave structure, if cave, the room number that the player is in, okay, we're going to pass that room like 1. If left, and remember we defined up, down, left, and right. Left is 2. If the second position, okay, in fact, I'll tell you what. Let's take a look at room number 1. Let's say let's say player position was equal to 1. Gotta go. I gotta go down to here. Cave. There we go. If it was equal to 1, left 0, 1, 2, okay, is equal to room number 2. Okay, room number 2. Like I said, this is probably the most difficult of all of the functions. And actually, I think I explained this in the first video. All right, what am I looking for? Check room, draw room. It's the events function. There we go. All right. So what we're saying is, hey, else if cave, player position, and the third number in that list is greater than 0, that means there is a room to move into. Set the player position equal to that number. And then move Wampus. Let's look at move Wampus real quick. It's a super simple function. We're going to say, hey, listen, there's this global variable we have called Wampus position, and we're going to be modifying it. If mobile Wampus equals false, okay, or random.randint 1 to 100 is greater than the move chance, okay, we're just going to exit. We're going to go back, because that means either A, we don't want a mobile Wampus, or our move chance. Our move chance is we've gone less than a move chance. For example, let's say we had a move chance of 90%. Okay, 90%. We said 90. If this is greater than that, if we got a 93, this random number, that means that we're not moving. So just return. Otherwise, we say exits equals cave Wampus position. Okay, we're going to get the list of exits from the cave. Okay, that the Wampus is in, or the room that the Wampus is in. Remember, that's going to return a list of 4 numbers for new room and exits. So what we're going to do here is we're going to go through each and every single exit. Okay. If the new room equals 0, okay, we're just going to continue because he can't exit out of there. If the new room is the player position, if it's the same thing as the player's position, we're not going to move. If it's in the bats list, we're not going to move. If it's in the pits list, we're not going to move because the Wampus will not move into a room with bats or pits. And finally, if and all of this is not true, we can say, hey, the Wampus position is equal to the new room. Okay? So all this does, this for loop, is it goes through each room number in that list. There'll be 4 of them. And just checks to make sure it's not room 0, which means there is no exit in that direction. And make sure that the player, the bats, or there's no bats, no pits, etc. in there. Now, in reality, I think in the original game, the Wampus could be in a room with a bat and could be in a room with a pit. And you might want to do that. It allows the Wampus to move around a little bit more. And on top of that, confuses the player, makes the game even harder. Because they might be in a room that gives them clues. It says the Wampus is nearby and a pit is nearby. But both of those rooms, or that room could be the same room. And to do that, to modify that, just take out the 2 lines. Like if you wanted them to be able to be in a room with bats, just take out both these lines right here. All right, and then once again, for debugging information, I just print Wampus move to, and it's going to tell me where he moved to. I would take that out once you have it working. All right, where were we? We were in the Check Pygame event. So I'm not going to go over each one of these because they're all essentially the same. This code right here, checking if the player moved to the left, is the same as checking for the right. Checking for up and for down. Okay, so they're all the same. All right. So once we did check Pygame events, we're going to draw the room. And I actually showed how to draw the room in the last one, but let's just go up because it got a little bit more complicated. So once again, what we're going to do is we're going to get the list of exits out of that room that the player is in. We're going to paint the whole screen black. Okay. Then what we're going to do is we're going to draw a giant circle in the middle. That giant circle in brown is going to represent the room. And so the circle radius is calculated based upon the screen width. Okay, notice the double division sign. That's integer division. So it returns an integer. I multiply by 0.75, and I convert the whole thing back to an integer. And technically, I could have done this, but whatever. I think when I was originally writing this, I was doing it differently, and so I had the integer division in there. But anyways, so what this does is it converts everything to an integer because circle radius, okay, needs to be an integer. Then I just draw that circle. We draw it to screen. We draw it in our brown color. And this right here is the center of the circle. The X and the Y coordinate. Notice once again that they are in parentheses because it wants a tuple or list. Tuple in this case. Tuple. However you pronounce that. Tuple, tuple. Tuple tuples are a lot like list, only they can't be modified. But nothing that you need to know about right now. So anyways, we're going to put it in the center of the screen. That's what screen width divided by 2 and screen height divided by 2. Notice it's the integer division so that we don't have a floating point number. Then this right here is the radius. And then this we don't have a border around the circle. All right, then we're going to draw all the exits. If exits left is greater than 0, in other words, if there is an exit off to the left of our room, because there's a number in our list, that's greater than 0, we're simply going to calculate where to draw that rectangle. We're going to draw a rectangle. Okay. And so what this does, we're going to put the left edge of the rectangle, because this is going left, at x coordinate 0. So it's all the way over here, x coordinate 0. And the top of it is going to be the center, okay, of the screen minus 40. So we're going to start drawing, okay, we're going to start drawing at x coordinate 0, the center, okay, center of the screen, all the way over to the left, up 40. And then basically we're just going to draw it screen width divided by 4. This is the coordinate for the top left of the rectangle. Okay, this is the x and y coordinate, which we calculated. Okay, left is going to be 0, so it's going to be all the way to the left, and the top is going to be up there. And then we're going to draw it screen width divided by 4, comma 80. This is the width that we want to draw it and the height that we want to draw it. So it's going to start over here, and it's going to draw a rectangle that's 250 pixels because our screen width is 1,000 and 80 tall. And once again, I'm not going to explain the rest of these because they all do it exactly the same way. Just the way they calculate it is a bit different. Okay. Now we're going to go and take a look. We need to find out, are there bats, pits, or a Wampus near? Okay, so bats near equals check neighbor rooms. And we're going to take the player position and the bats list. So let's look at check neighbor rooms. All check neighbor rooms does is it checks to see, hey, this room number that I got passed a position and the item, okay, is that position in that item list. So what we do is we say exits equals cave position, okay. Oh, actually, we don't even need this. I was doing this differently before. So what it's going to do, okay, what it does, it says return any, okay, item in cave position for item in item list. So all this does, it's a fancy for next loop, okay. We've got the item list. Once again, we're going to pass to it the first time, maybe the pits list, okay, the bats list, etc. For item and item list, and that's the list of rooms. So maybe the bats are in 4, 8, and 7. Okay, and our position, has, what this does is it returns that list. Okay, and it's just checking to see, hey, does the list of, say, bats, do any of those numbers appear in the list of exits? Okay, the list of exits from this current room. And if it does, we're going to return true. All right, so let's go back over here to draw a room. And so we're going to check and see, okay, are there bats near, pit near, and is there a Wampus near? And we're going to use that check neighbor rooms, but we have to do something a little bit weird here. Remember that it's wanting a list, and Wampus position is just a number. That's it, nothing more. We basically make a fake list and pass it in that has the Wampus position in it, and then we put -1s in for the rest of them. All right, so now if Wampus near is true, we're going to draw a circle, a red circle dead smack dab in the middle of the screen to let us know that the Wampus is in a nearby room. Draw the pit in black if it is present. Now, here's the deal. If player position is in pit's list, that means they've fallen into a pit. If player position, the current player position, is in the list of pits, we're going to draw a black circle. Okay? And we say Pygame draw circle screen black, etc. Then we're going to draw the player. And that's what screen.blit does. It's going to draw on the image, okay, screen.blit, player image. Remember when we assigned this a long time ago. Okay, when we loaded, we had a variable called player image. And we're going to put it at screen width divided by 2. Okay, we're going to put them in the dead center. Screen width divided by 2 minus the width of the player divided by 2. Screen height divided by 2 minus the player image height divided by 2. And the reason why we do that is all images in Pygame are referenced by the top left corner of that image. So if we'd actually done it right in the dead center, he would be offset. He wouldn't be in the center. We're going to do the same thing with the bats. If player position is in bats list, in other words, if there's a bat in the room, we're going to do exactly the same thing as we did up here. We're going to draw the bats, bat image. Once again, we're going to put them in the dead center of the screen. So they're going to actually draw over the player, which makes it look like they've picked them up. And then finally, if the Wampus is in there, we're going to draw the Wampus. Then finally, last thing we do in all this is draw text. The Y text, and remember the text is going to start in the upper left and move down. Okay, Y text position equals 0, so we're going to keep track of the Y position. Okay, of where the text should be drawn. We're going to say position text equals font.render POS. That's the position, where they're at, what room number they're in. Okay. And we're going to say it's equal to POS, the text, the literal text POS, plus we're going to convert the player position to a string. Okay. And we're going to, this is the color. Okay. And then we're going to draw it on the screen. Screen.blit, position text, comma, 0, comma, 0. So we're going to draw it at 0, 0. This is the X and Y coordinate to draw that image. Okay. Then we're going to make arrow text. We're going to tell you the player how many arrows they have. Same thing. Font.render is going to make a image. We're going to do arrows, plus we're going to convert this variable num arrows to string. And we're going to do it in this color right here. I think that's a greenish color. And then the same thing. Now what we're going to do is Y text position, okay, is equal to Y text position, which was 0 up here, plus position text dot get height plus 10. What this does is it's going to get the height, okay, of this image that we put up here, the position text that we made. And we're going to add 10 to it. And that's going to be our next Y position, where we're going to draw the next text. And so we're going to say screen.blit, arrow text 0, that's the X. We want all the way to the left. And then Y position text, we're going to move down. Now, we're going to do the same thing. I'm not going to go over all of it. If bats are near, we're going to do the same thing. Only we're going to say you hear the squeaking of bats nearby. And then we're going to draw that. We're going to reset our Y position where we're going to draw a little bit further down. We're going to say same thing if pits are near. We're going to do the same thing. We're going to put you feel a draft nearby. And finally, the last thing we do, if player position is in bats list, in other words, if there's bats here, we're going to go ahead and flip the display and wait just a bit. Okay, we're going to say pygame.display.flip. We're going to wait 2 seconds. Okay, and then we're going to go all the way back down to our main game loop. Whew. Now we're going to do pygame.display.flip, which just flips it, and then finally we're going to check room. So let's go over here to check room. All right, so check room. Is there a Wampus in the room? And it takes the player's position, okay? Is there a Wampus in the room? If player position and Wampus position are now the same, we know we ran into the Wampus. Game over, you were eaten by a Wampus. Is there a pit? In other words, if the player position is in the pits list, we're going to say game over, you fell into a bottomless pit. Is there bats in the rooms? This is the most complicated function here. Okay, bats, we're going to say, hey, bats pick you up and place you elsewhere in the cave. What we're going to do is we're going to fill the whole screen with black. Now, remember, we waited 2.5 seconds. Okay, and technically, I probably could have done that here. All that stuff I did. But if player position and bats list, bats pick you up and place you elsewhere in the cave, we're going to fill the whole screen with black. We're going to make a text, and we're going to make it red, that kind of greenish color. We're going to put it in the dead center. Okay, what text rectangle equals bat text dot get rectangle. What it does is it simply gets the bounding rectangle that text takes up. And we're going to say text rectangle dot center x is equal to screen dot get rectangle dot center x. That's going to get the center x and y coordinates of our screen. We're going to screen dot blit it. We're going to, in other words, draw bat text. Whoops. We're going to flip the display, wait 2.5 seconds. Then what we're going to do is we're going to move the bats, okay, to a new position, because the bats are now in a new position. And that's what all this code right here does. And it's really the same. And I probably actually could have called our place bats function. Now that I think about it, might have been better to do it that way, but this works. And then we're going to move the player, okay? So now we're going to say new position equals player position. Set the new position, okay, equal to the old so that the first test fails. Once again, this is one of those deals where we're going to make sure that the first test fails because we know that's not what we want. And we're just going to keep choosing a random player position, okay, and making sure that the new position of the player isn't in a room with a bat, it isn't in a room with a Wampus, and it isn't in a room with a pit. Now, if you want to make this game more deadly, you can actually take this check out, okay? In fact, the old game, if I remember correctly, could dump you in a room with a bat, which means then you then got placed in another random area. Or it could put you in the room with a Wampus, meaning that you died, or in a pit, meaning you died. So if you want to make the game harder, take out this right here, okay? Just take it out. And, what you're going to do is you're going to take out the while. Leave the new position equals random, .random 1 to 20 in there. Because that's going to select a new random room for the player. And which in that room could very well have bats, a pit, or the Wampus in it. And then, once again, I print this out, but where the new player position is. But once again, you might want to comment that out. Then finally we check to see if there is an arrow in the room, okay? And if there is, we're going to do kind of what we did with the bats up here. We're just going to print in the center of the screen, hey, you found an arrow. And then we're going to add 1 to the player's arrows. And I think the final thing I got to show you is the shoot arrow. So let's go over here. So shoot arrow. We're going to assume we don't hit the Wampus, okay? We're going to assume that the player is wrong. We say if num arrows equals 0, return false. Okay, so if you got no arrows, you can't actually shoot the arrow. So then what we're going to do is we are going to subtract 1 from our number of arrows. And we're going to say if Wampus position equals cave player position, comma, direction. Because remember, we passed a direction up, down, left, or right. Okay? So basically what we're saying, hey, if in our dictionary that we have called cave, if let's say the player was in number 8 and we went left, and we said, hey, if the Wampus position is equal to wherever the player is and the direction they shot, hit equals true. And we're good. So we say if hit equals true, we're going to say game over. Your aim was true. You've killed the Wampus, and we're going to quit and get out of there. Else, we're going to put your arrow cells into the darkness, never to be seen again. We're going to place the Wampus. So we're going to move the Wampus, actually. The Wampus moves. And then we're going to say, hey, but if your number of arrows equals 0, you're out of arrows. You've died. Game's over. And so that's pretty much it. Let's run it. Make sure it works. Hello from the Pygame community, blah, 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 blah. Gives us some instructions. Press enter. So here we go. Let's play it without looking at all this right here. So I'm going to go left. Oh, we fill a draft nearby. So we know that either to the left or up is a pit. So let's go right again, back to where we started. Let's go right. Ooh, the Wampus is nearby. This could be a short game. All right, let's go up. And then let's go right. Okay, down. Oh boy. This is difficult. I think he's to the he would be to the left. Let's press shift and left. Because remember, to fire our arrow, we press the shift key. So I'm gonna press shift and left. Your arrow. Oh my god, I missed. You are out of arrows. You have died. So I didn't do it right. Let's play again. Let's play again. Okay. All right, here we go. Let's go up. Draft nearby. That means we've got a pit. Let's go down. Ooh, once again, the Wampus is nearby. Oh boy, this is scary. He's got to be to the left, doesn't he? I'm gonna go left. Your aim was true. You have killed the Wampus. Yeah. All right, so that's Hunt the Wumpus. Make whatever changes you need, and if you find any bugs or anything, let me know. I do not guarantee this to be bug-free. In fact, I found 1 or 2 as we went down through it. If you got any comments down below, leave them down below. I really appreciate it if you subscribe to the channel and like the video. And hey, if you want me to see me make a game or write some kind of a program, just let me know down in the comments below, and I'll get working on it. I've got some really cool stuff planned. I've got this thing, genetic letters, about genetic algorithms, and I've got some stuff on machine learning and a few other things planned. But anyways, until next time, today was a great day to learn how to code, and I'll see you next time. Bye-bye.